Welcome to our video on the history and evolution of AI. In this 8-minute journey, we'll explore the fascinating timeline of artificial intelligence, from its humble beginnings to its modern-day applications. So, let's get started. AI's roots can be traced back to the 1940s and 1950s when the pioneers of computer science began envisioning machines that could mimic human intelligence. One notable figure during this era was Alan Turing, whose work on the Turing test laid the foundation for AI research. In 1956, the Dartmouth Conference marked a significant milestone for AI. It was a gathering of leading scientists who coined the term artificial intelligence and laid out the goals and aspirations for the field. This conference acted as a catalyst for the emergence of AI as a distinct discipline. During the 1950s and 1960s, researchers developed early AI programs that focused on symbolic reasoning and logic. One notable achievement was the logic theorist, developed by Alan Newell and Herbert A. Simon, which could prove mathematical theorems using formal logic. In the 1970s and 1980s, AI research shifted its focus towards expert systems. These systems utilized rule-based programming to capture and mimic the knowledge and expertise of human specialists. One prominent example was Mycin, a medical expert system designed to diagnose bacterial infections. However, in the late 1980s and early 1990s, AI faced a significant setback known as the AI winter. Funding for AI research declined, and there was a period of reduced optimism about AI's potential. It was a challenging time for the field, but it also paved the way for future advancements. The late 1990s witnessed a resurgence of AI, thanks to several factors like improved computing power, availability of large datasets, and breakthroughs in machine learning algorithms. Researchers began exploring new approaches, such as neural networks and genetic algorithms. In recent years, AI has made remarkable strides. Deep learning, a subfield of AI, has revolutionized the field with its ability to learn from massive amounts of data. Breakthroughs like AlphaGo's victory over a human champion and OpenAI's GPT-3 language model have demonstrated AI's potential. Today, AI is transforming various industries. From autonomous vehicles and virtual assistants to healthcare diagnostics and personalized recommendations, AI is making our lives easier and more efficient. It's a testament to the progress and impact of AI on society. And that brings us to the end of our History and Evolution of AI video. We've journeyed through the early origins, witnessed the setbacks and resurgences, and explored the incredible advancements of AI. Remember, AI continues to evolve, and the future holds even more exciting possibilities. Thank you for watching, and we'll see you next time. Welcome to our video on Machine Learning Fundamentals. In this session, we'll introduce you to the basic concepts of machine learning and explore some key algorithms. So, let's get started. First, let's define what machine learning is. Machine learning is a branch of artificial intelligence that focuses on developing algorithms and models that enable computers to learn from data and make predictions or decisions without being explicitly programmed. Machine learning can be broadly categorized into two main types: supervised learning and unsupervised learning. Let's start with supervised learning. In supervised learning, the algorithm learns from labeled data, where each data point has a corresponding label or target value. The goal is to teach the algorithm to predict the correct label for unseen data points based on patterns and relationships in the labeled data. There are several supervised learning algorithms, and one of the simplest is linear regression. Linear regression is used to model the relationship between a dependent variable and one or more independent variables. It assumes a linear relationship between the variables and finds the best fitting line that minimizes the difference between the predicted and actual values. For example, if we have data on housing prices and features like the size and number of rooms, we can use linear regression to predict the price of a house based on those features. Another popular algorithm in supervised learning is decision trees. Decision trees create a flowchart-like structure of decisions based on feature values to reach a prediction or decision. Each internal node in a decision tree represents a decision based on a feature, and each leaf node represents a prediction or decision. Decision trees are easy to interpret and can handle both numerical and categorical data. For instance, in a decision tree for classifying animals, we might use features like, does it have fur? and does it lay eggs, to predict whether an animal is a mammal, bird, or reptile. Now, let's move on to unsupervised learning. In unsupervised learning, the algorithm learns from unlabeled data without any predefined targets or labels. The goal is to discover patterns, structures, or relationships in the data. One common unsupervised learning algorithm is clustering. Clustering aims to group similar data points together based on their inherent similarities or distances. For example, in customer segmentation, clustering can be used to group customers with similar purchasing behavior, enabling businesses to tailor their marketing strategies. Another notable unsupervised learning algorithm is neural networks, which have gained immense popularity in recent years. Neural networks are composed of interconnected nodes, or artificial neurons, organized in layers. They can learn complex patterns and relationships by adjusting the weights of connections between neurons. Neural networks have shown remarkable performance in various tasks, such as image recognition, natural language processing, and voice recognition. And that brings us to the end of our Machine Learning Fundamentals video. We've covered the basics of machine learning, including supervised and unsupervised learning, as well as some key algorithms like linear regression, decision trees, and neural networks. Remember, machine learning is a vast field with many more exciting concepts and algorithms to explore. Thank you for watching, and we'll see you next time. Thank you for watching, and don't forget like, share and subscribe our channel.